Right, so can you guys see my screen now?
Yes, sir.
Yes, sir.
All right, good. So, so while let's say we will discuss this one, so you can eat, okay? So you can eat your breakfast. You can grab a coffee or a milk or even a Milo, so anything that you want, so that because it's better if you have a food inside of your stomach, so uh, it won't distract you. Let's say if you're hungry, all right? So first, our very first topic is intro to Electro. Okay, so the very first question that you might ask is, what is electronics? Okay, so to make it simple, okay, I made it simple as possible. So the very definition of electronics is, it is the study of how to control the flow of electrons. Okay, so anything that is concerned with the study of this one, the flow of electricity or electrons, then that is already electronics. Okay, or in other words, it deals with circuits made up of components that control the flow of electricity, okay, such as vacuum tubes, transistors, diodes, integrated circuits or IC, optoelectronics, and sensors associated, passive electrical components, and interconnection technologies. All right. So again, I repeat, electronics is the or a device or a thing that study or control the flow of electrons or electricity. Okay, so I hope that this one is clear to you. Okay, so electrons or electronics is not just a single component or not just a single device. So it is anything that studies about the flow of electrons or the flow of electricity. Okay, so let's talk about some basic or common electronic components. Right, so an electronic component is any physical entity in an electronic system used to affect the electrons. Okay, so it is very obvious. Okay, any physical entity, as long as it has a physical uh, form that can deal with or that can affect about electrons, okay, or in other words, electricity, or any other associated fields, then that is already an electronic components. Okay, or to make it simple, anything that can control or that can affect uh, the electricity. Okay, that's it. Okay, that's already an component. Okay, so components are generally intended to be connected together. So of course, this is very simple. So there are some components that has a lot of components, and then there are other components that is one or single component only. All right, so of course, if you connect those components together, so you might solder those components to a PCB or a printed circuit board to create an electronic circuit with a particular function. Like for example, that circuit or that uh, PCB might amplify, or it can amplify, or it can receive a radio signal or an oscillator itself. Okay, so there's a lot of uh, functions, or there's a lot of what do you call this one, mm, purpose. Okay, there's a lot of purpose that you can do with this component, and then if you combine those two components, then there's another purpose for that one. Okay, so again, as I said a while ago, so it can be connected together and then put it into a PCB, or that component may be packaged singly. Okay, or in more complex groups as integrated circuit if it's grouped together or connected together. Okay, so some common electronic components are capacitors. So this one is singly. We have inductors, resistors, diodes, and then transistors, and etc. So there's a lot of other uh, components that you can think of. Okay. And then lastly is components are often categorized as active or passive. So for active, we have transistors and then thyristors. And then for passive, those are the resistors, diode, inductors, and capacitors. Okay, and many more. So if you have a question or clarification or concern, so you may interrupt me anytime. Okay, so just raise your hand or you can just really interrupt me. So no problem with that. Okay, so you don't need to ask permission to ask a question. So just speak up. Okay, so no problem with that. All right. So after this one, electronic components, this is are the basics. So there's actually a lot more when it comes to electronic components. But we will discuss the other components soon. Okay. For now, let's discuss the history of electronic components. Okay, so the very, very first, or the earliest actually, not the very first component. The earliest electronic component is the vacuum tubes, or in other terms, they call this one thermionic valves. Okay, so this one were almost solely responsible for the electronics revolution of the first half of the 20th century. Okay, so as some of you may recall, some of our TV before, like at the age, maybe my age before was 6 years old or 7 years old, we have a TV. And then that TV is fat, a large one, okay, a box TV, wherein it is using a CRT or cathode ray tube, wherein of course it has a technology of vacuum tubes. Okay, so that is one good example of usage of vacuum tubes or a component of vacuum tubes. So this one allowed for vastly more complicated systems and gave us the radio, television, okay, the large one, not the flat television that we have today, phonographs, radar, long distance telephony, and then much more. Okay. So this one played a leading role in the field of microwave and high power transmission, as well as television receivers until the middle of 1980s. So my father and mother used to have those technologies. So yeah, but until now, of course, but they are already also, but this is their era. Okay. Our era today is, of course, the slimmest, the flattest, the curves, and then some are already transparent. Okay, so since that time, solid state or see solid state, those are semiconductor devices already. So solid state devices have all but completely taken over. Okay, so that's where the era of vacuum tubes end. Okay, because someone have already discovered this semiconductor or this solid state device. So why solid state? Because it's a non-moving component. Okay. For vacuum tubes, it has a moving particles, like it releases heat, and then it will be, uh, let's say, after heat, there's a gas. I think since vacuum tubes has gas inside, and then yeah, of course, those gas or those electronics or electrons rather, move. Okay, and then creates an image or provides a sound by radio. Okay. So vacuum tubes are still used in some specialist applications such as high power RF amplifiers, cathode ray tubes. Yeah. So this one is the one that we have before for the television. And then specialist audio equipment, guitar amplifiers, and some microwave devices. Right. So those are the basics when it comes to vacuum tubes or vacuum tubes. So do you guys have a question so far?
None, sir.
All right.
Wala naman.
Okay, that's good. So again, if you have a question, so you can uh, ask anytime. All right. So moving on is electricity. Okay. So but before that, before we talk about electricity, we have to know the foundation of electricity. Okay, so that is why we have here atom. Okay, so as we all know, atom is the smallest matter in the entire universe or the entire Earth, because that is what our scientists find out or found out in this world. I don't know uh, in other universes or in other uh, spaces. Maybe there's a smaller particle that we haven't discovered yet. So the Greeks believe that matter can be broken down into very small, invisible particles called atoms. Okay, and then those Greek philosophers or those Greek people are the Democritus and then John Dalton. So they're the one who put forward the concept of the atom. Okay, so when say atom, of course it means indivisible. You cannot divide it anymore. But it's quite weird since an atom has a structure or has a smaller particles inside of it. Okay, so here's the structure of an atom, and then it can be easily divided into two parts. So quite weird, right? So they said that atom is already the smallest particle, but you can still look for the smaller particles or the composition of that matter. Okay, so we have here the atomic nucleus, which is composed of proton and neutron. And then the others are just extra nucleus part, which is the electron. Okay, or to make it simple, it has three parts. Okay, the proton, neutron, and then electron. Okay, so the proton is the positive ion, and then electron is the negative, and then neutron is the like the neutral part. Okay, so take note that a conductor has 1 to 3 electrons. So take note on that one. And then semiconductors has exactly 4 electrons. And then an insulators, uh, it has exactly or ranging from 5 to 6 electrons. So are we clear on this so far? So take note on this one. This is very important. So this has a very big role uh, to electronics, okay, or to our preceding topics. So conductors has 1 to 3 electrons. Semiconductors has exactly 4 electrons, and then for insulators we have 5 to 6 electrons. So it seems like the lesser the electrons, the higher the conductance. Okay. So the lower, sorry, the lower the electrons, the higher the conductance. Okay. So the higher the electrons, the lower the conductance. Okay, or vice versa. All right. So let's now talk about electricity. So there are two types of electrical signals. Oh, covered my. Should edit this one. So there are two types of electrical signals: the alternating current and then the direct current. So don't worry, this one and direct current. It's just covered by this picture. Didn't notice this one, sorry. So we have the AC and then the DC. So I hope that you already have an idea about AC and then DC. So to make it simple, AC is the alternating current, okay, or it is measured in hertz, okay, or that one is in sine wave. Okay, could be square wave, sine wave, what else? Triangle wave, and any other waves. Okay, so alternating current, or this one, electricity flows in alternating direction. Okay, so very straightforward or very obvious. So this kind of current is measured in hertz. Okay, so direct current, very simple. Direct, it only flows in one direction. Okay, so I hope you already get the idea of those kind of currents. Okay, so for our AC, that is coming from, yeah, this one, 220 volts, or some are 120, 110 volts. So direct from the outlet. So the one that is being output on this outlet is alternating current or AC. And then for DC, of course, a battery. Okay. This one only produce a direct current or one direction current. Okay. So a circuit is a complete and closed path through. So as always, I think there's no circuit that is an open circuit, because if it's an open circuit, okay, it will not create a path for the electricity, meaning it's a dead component. Okay, it doesn't able to receive and then deliver the electricity. So to make it simple, a circuit is always a uh, closed path circuit, okay, or closed path through which electric current can flow. So in other words, a closed circuit would allow the flow of electricity between power and ground, and then an open circuit would break, okay, the flow of electricity between power and ground. So if there's no connection between power and ground, then that's a dead component. Okay? So that is where our VOMs uh, is checking if there's a connection between the power and the ground. So for the closed circuit, of course, we have the connection for the power and then the ground. And then for open circuit, maybe the ground is the only thing that is connected, and then the other one is not connected, or vice versa. The power is the only one that is connected, and then the ground is not connected. Okay. Any questions so far?
None, sir.
All right,
None, sir.
that's good. So again, if you have a question, so please feel free to ask anytime. All right, so let's talk about basic components. So we have here an LED transistor. You got this one? Forget the name. Later, we will see what is the name of this one. Potentiometer. Yeah, remember potentiometer, switch, and then a capacitor. So this one is the non-polarized and then a polarized capacitor. And then we have an IC, a diode, and then a resistor. Okay, so first we have to discuss what is resistor. So it's the very first component that I've learned when I was in college. Resistor, and of course it's also very obvious. Okay, because as its name implies, resistor, it resists, okay, or it reduces the flow of electrical current in that path or in that wire. Okay, so this one adds resistance to the circuit and reduces the flow of electrical current. So it is represented in a circuit diagram as a pointy squiggle with a value next to it, like this. Okay, so in electrical diagram or electrical circuit, so this is the symbol. Okay, squiggly, pointy squiggle uh, line, and then it has a value next to it, which is 47 kiloohms. So the different markings on the resistor represent different values of resistance. These values are measured in ohms. Okay, so if you're going to take a look closer on those resistor, it has 4 bands of colors. So those colors has meanings. Okay, so and also of course different colors represents different uh, value, okay, of resistor or different value of resistance. Okay, so you might want to check that one on the internet. So you will see what is the value or what is the exact value of that resistor. Okay, so you read or we read the values from left to right towards typically gold band. Okay, so basically it is like this. We have first three band, and then we have like space on it, and then the last band is always like gold, silver, sometimes red, yeah, sometimes also brown, but mostly it is gold or silver. Okay, that is the common color of the last band. And then yeah, we done with this one. So you can tell the value of each color by looking at a color value chart. So we have a chart Where is the, I think this one. Yeah. Oops, what happened? Cannot connect. All right, so wait a second. Let me just show to you color calculator. All right, so there's actually a lot of website or a calculator website that can compute the resistor value. So as you can see right here, we have, or you can choose 4 band, 5 band, or 6 band. But the most common is 4 bands resistor. So all you have to do is choose a color, depending on the color of what resistor you're holding. Say that resistor for the first band is orange, and then the second one is yellow, and then the third one is green, say. And then let's say gold for the tolerance. So it is something like this, wherein the first band of color and then the second band of color represents the number 34. And then the third one is the multiplier. So 34 times 100 is 3,400. This one is in kilo. Okay. So 3,400 times 1,000 again. So that's a million already. So 3.4 M. Okay. And then we have a tolerance of 5%. So meaning it has a let's say ranging from this 3.4 M plus 5% of that one, or lesser than that one, or less 5% of 3.4 M. So it has a range or an acceptable value within that range. Okay. So yeah, sometimes it's not accurate. It's not really 3.4 M, but sometimes it's 3.45 M or 3.38 M or 3.35 M. Okay, so that's how you compute the, or that's how to know the value of the resistor. Okay. So any questions so far?
None, sir.
All right. Next one is capacitor. So a capacitor is a component that stores electricity and then discharge it. Okay. So this capacitor or this circuit or this component only do this if there's a drop in electricity. Okay, so this doesn't really do anything in our circuit. It's just that if there's a fluctuation or if there's a drop of electricity, then that's where the role of capacitor came from or will go. So you can think of it as a water storage tank that releases water when there is a drought to ensure a steady stream. Okay, so the same with electricity so that it can maintain a stable or a constant uh, flow of electricity. So this capacitor is the one is in charge with that one. Okay, so it stores electricity and then discharge it if there's a drop of electricity. So capacitors are measured in farads. I forgot this one is measured in ohms. Okay, capacitors are measured in farads. So the values that you will typically encounter in most capacitors are measured in picofarad. Okay, and then some are nanofarad, and then the last one is microfarad. Okay, so mostly we measure that one in picofarads. This is the smallest, okay, smallest value of capacitors, and then the biggest one is the microfarad. And then these are often used interchangeably, and it helps to have conversion chart at hand. Okay. So the most commonly encountered types of capacitors are ceramic disc and then the electrolytic capacitors. So for ceramic disc, as you can see, this ceramic disc looks like M&Ms or smaller and flatter version of capacitor. Okay, with two wires sticking out them. So we have first wire and then the second wire. And then the second one is electrolytic capacitor, the bigger one. Okay, this one is more like small cylindrical tubes. Yeah, it's cylindrical with two wires coming out from the bottom. So the same. So as you may see right here, or as you can see right here, the connection of the ceramic disc capacitors are the same. Or yeah, they are the same when it comes to length. But for the electrolytic capacitors, as you can see, the other one is shorter and then the other one is longer. So for this one, this doesn't have a polarity. So you can interchange the connection of ceramic disc. But for electrolytic capacitor, we have to follow the polarity of this one. So the smaller one is the positive and then the smaller one is the negative, I think. Let's see. There's no other. So yeah, the smaller one is the negative, I'm sure. And then the longer one is the positive. Am I correct? Is there anyone who's familiar with the usage of capacitors? Which one is the positive? Long or the short one? Because for LEDs, the longer one is the positive, and then the shorter one is the negative. How about for capacitors? Which one is the positive? The longer one or the negative? The longer one, the shorter one.
Sir, negative po yung shorter one, tas longer yung positive.
Yeah, yeah, yeah. All right. So they're the same with LED. So shorter one is negative, and then the longer one is the positive. Okay. So continuation for this capacitor. So ceramic disc capacitors, yeah, as I said a while ago, it's non-polarized, meaning it doesn't have a polarity. So you can use any of those uh, stick or any of those output or wire. So meaning electricity can pass through them no matter how they are inserted in the circuit. But for electrolytic capacitors, they are typically polarized, okay, meaning it has a polarity. So this means that one leg needs to be connected to the ground and then the other one should be connected to the power. So if it's connected backwards, then it will not work. Okay, it will not accept uh, power on that one. So electrolytic capacitors have the value written on them, typically represented by the microfarad. They also mark the leg which connects to ground with a minus symbol. Okay, so I'll stop here for now since I think we now only have 20 seconds. So wait for the part two. Okay, wait 5 to 7 minutes since I need to convert this video or this pre-recorded video. Okay, so bye bye for now. See you in part two. Okay, so have a break 5 to 7 minutes.